So, hello, my name is Georgios and I'm assistant professor at the Aristotle University of Thessaloniki and a senior researcher at the Embedded System Design and Application Laboratory of the University of Peloponnese in Greece. In this talk, I'm going to give a brief overview of the Xandar project. As you can see in the slide, the full title of the project is X-by Construction Design Framework for Engineering Autonomous and Distributed Real-Time Embedded Systems. Xandar is a H2020 Research and Innovation Action European funded project. The project started this year and will last for 3 years. The official website of the project can be seen at the bottom of the slide. The target call of Xandar was the ICT 50 call that was dedicated to software technologies under the subtopic Development Tools and Methods for Interoperable, Adaptive, Secure and Trustworthy Software. Without delving into too many details about the call, this slide depicts some selected keywords from the corresponding H2020 work program. Those are development of processes and tools for building trustworthy software that adapts to rapidly changing requirements while maintaining key qualities like reliability, availability, performance, security, and privacy. Another key phrase is the transparent and unbiased algorithm decision making for the end users. Yet another important phrase is to build software engineering tools with increased validation, verification, and testing capabilities. Finally, the solution developed in the project must be showcased in highly heterogeneous environment with wide geographic distribution, unreliable connectivity, unpredictable affinity to data sources, and also component in various cyber dangerous environments. Having highlighted the objectives of the call, I will continue by presenting the Xandar consortium. As you can see, the consortium is well balanced between academia and industry. More specifically, the project consists of 8 partners, 1 research organization, 1 research center, 2 SMEs, 2 universities, and 2 large organizations. In the bottom of the slide, you can see all the partners of the project, and of course, more information about the role of each partner can be found on the website of the project. To continue, this slide depicts the X-by construction approach followed by Xandar. We rely on a model-based workflow and the smart runtime software stack. More specifically, the Xandar process first builds models for the logical and the software architecture of the target use cases. This allows us not only to increase the productivity time of the software development, but also to early validate the system by simulating the software implementation in a model environment. The end result of the project will be a library of software components with different implementations and different performance, safety, and security guarantees. The next slide shows the main tools of the Xandar approach. Those are the prevision tool of Vector, targeting to build the logical and software architecture. The second tool is Ptolemy 2. This tool will be appropriately extended to simulate the whole system in a dynamic environment. And finally, there is the Xandar toolchain, targeting to offer the following features on top of the previous tools. Those are to generate the software component skeletons from the system models, to integrate the software components in revision, and to integrate the necessary software safety security mechanism, and finally to generate the optimized code for the target system. Since Xandar targets distributed and connected systems, the concept of cybersecurity is an important design consideration, equally important with functional safety. This is because any latent cybersecurity vulnerabilities within the autonomous system can be exploited by an attacker, causing system malfunction or failure. So the question is, how can we identify and analyze such risk? In Xandar, we are adopting the use case driven hazard analysis and risk assessment and threat analysis and risk assessment approach, which is in line with the emerging security and functional safety standard. Going to the end, the Xandar approach is going to be validated in two different use cases. The first use case is provided by the German Aerospace Center and focuses on urban air mobility or UAM. UAM is defined as a safe and efficient way of transporting passengers and cargo in and around the urban area. The challenge is that high levels of automation in UAM requires resilient architecture to achieve fail operational and fault tolerant control of flight, secure communication of flight clearness, and detecting and avoiding hazards in order to conduct safe missions. The second use case is provided by BMW and it focuses on autonomous systems with integrated machine learning applications. The current status is autonomous driving system mostly to work in an isolated manner. However, according to industry projections, a highly interactive environment infrastructure for autonomous driver car is a vision in order to implement new mobility patterns in a more efficient, ecological, and cost-effective manner. This was the end of my presentation. I will be happy to answer any questions.